Okay, so what does dimension mean here? Well, what it actually refers to is the number of variables. Okay, well, we saw on the previous video that we've got 5 variables, so the summary data has dimension 5. The 5 attributes or variables or columns are the price, profit, sales, marketing, and cost. Okay, so that's an easy definition. You could just look at the number of columns, although of course you can transpose your data, so that's not always a good way of telling. But typically, when you've got the data in a form that you want it, it's going to be perhaps the number of columns. But it technically refers to the number of variables. If you think about the daily sales data, how many columns have we got there? Well, we've got 25 different products. Each product has a column, and therefore that data set, the daily sales data, has a dimension 25. But actually, the daily sales data is actually, in a lot of ways, it's easier to make comparisons because all the variables are measuring the same thing, which is the same sales per day. And when we're talking about the summary data, it's not so easy to make comparisons because we're measuring completely different things. So if you think about we haven't looked at the data in particular detail yet, but if you think about the price, the profit, and the cost, they tend to be measured in pounds, and the values go from between, I don't know, 5 to 50 pounds, something like that. The marketing is the amount of marketing spent over the whole year, so that's thousands of pounds. And the sales, as we've seen, is the number of products sold, which can go up to, I think, is it about 175,000 products sold. So they're very different sizes. Okay, so first of all, let's get a sense of what we've got then. So we'll draw a bar chart of each attribute. And you can do that simply by looping over the summary data. You can do this with a data frame. If you loop over a data frame, so using a Python for loop, that just each attribute is just a column of the data frame. So you're allowed to iterate over a data frame like this, and you just, every time you go around the loop, you get a different column. And so I can I can do exactly as we did before. I can draw a bar chart of that column and visualize all the values on it in a bar chart to get a sense of the proportions. So the single line, the bar chart itself is created by this one line here. This is just like we did in the second lecture. It's exactly the same code. It's just that now I've put this code in a loop, and the thing that creates the bar chart is this one here. We've got numpy to just create a range of numbers between 1 and 25, and then we plot that on a bar chart, and then we've got some lines to put some labels on it. Okay, as I said, numpy calculates the positions for the bars and tick marks, and then the tick marks are just the product names, which we then put on the x-axis. So this x pos is x positions, and we just put the index, which for the summary data frame, the index is the name of each product. Okay, so that's what it looks like if I do the price. And so immediately you can tell, okay, the price varies from maximum of 50. There's nothing quite gets to 50 there. I don't know if you may not be able to quite see that, but the top number there that I'm hovering over is 50, goes down to 0, and you can see there looks like there's one there. The price for that product Q is maybe 8, something like that. Okay, there's the profit. Obviously, the profit should be less than the price. The profit's the amount of the price minus the cost, and so you can see for some products it's very low profit. Again, this goes up to, this is not the same scale, notice. So the maximum number here, again, I'm not sure you can read that, but the maximum number is 25. So the highest profit is 25 for product U, and it goes down to about maybe £2 per unit sold for product P. Okay, so it's some range between 2 and 25. There's the sales. We knew about this already because we did this essentially in lecture 2. Okay, and you can see there, there's the sales, and what we knew already was that A, F, and L are the high volume products, and they're up to around 175,000 is the maximum there. Okay, but a very, very different scale from the other charts. There's the marketing costs. So this is the number of pounds per year spent on a product. Okay, and that ranges from actually here L, there's nothing spent on marketing this product, up to what's that, around about £43,000 for marketing this product U. So very big different set of ranges of the values. Finally, the cost. This is if we go back a couple of slides. So the cost is one of our calculated variables. We calculate it by taking the price. Price is what the product is sold. But be careful with the words cost and price because they can mean different things in different contexts. In this context, the price is what the consumer pays, person who buys the product. The profit is then the difference between the cost and the price. So the cost is, put it another way, the cost is what the company pays to get hold of the products. The price is what they sell them for, and the profit is the number in between that. So going back to our picture, there's the cost. Okay, again, so this could be derived from those other two charts, and you can see the cost there goes between around about 45 down to about 5. So some products are cheap for the company to buy, some products are quite expensive. And although we can see that there's from each particular variable, we can see which are the maximum and which are the minimum quite easily from these plots, it's almost impossible to see how one variable impacts on another. Or if they do at all, we don't know that yet. So that's what we're going to be exploring in this lecture. So how does one thing impact on another? Are there relationships there that we could use to help the company understand their data? A second way of doing that is to use subplots. Okay, so here's our typical code for doing subplots. This is exactly the same as we've done before. Okay, whoops, go back again. But again, we end up with these 5 charts. So this is just showing the 5 charts that we saw on the previous slide, but all in one picture, using faceting or subplots. But again, you can see that all the variables have very different scales. I mean, it maybe helps to eliminate some things, having them all in one picture, but I think that would be it's hard to determine anything from this set of pictures. There's no obvious relationships. It's not obvious, for example, you might think if there's very high sales, then there might be very high marketing. You might expect, maybe that the company spends a lot on marketing those products. That isn't the case. You can see there's no obvious correlation between those 3 very high selling ones and the marketing spend, which can be very high on other products. So what we're going to have to do in this lecture is try and get more sense of what this data is really telling us, and explore that using different visualizations. Okay, I'm going to finish that video there, and then we'll move on to look at normalization.